In section 4 of chapter 2, we're going to add variables on both sides of our equation. So by the end of this lesson, you should be able to solve equations with variables on both sides and solve equations involving grouping symbols. So for the most part, they're going to be parentheses. So think back to how we solved things yesterday. Remember that when we simplify, we use GEMDIS. And since solving is the opposite of that, we got to go backwards, and we'll use SADMEG to undo things. So let's say I gave you something like 2 plus 5k equals 3k minus 6. So the difference here between the problems we were doing yesterday and these problems is that there's k's on both sides of the equation. So you get to make a choice if you want to put all of your k's on the left side or the right side. And there's really no right answer here. I'm going to move mine all to the left, just so that when we get done, it says k equals something. So in order to do that, I need to move this positive 3k over to the other side. So all I have to do is subtract it from both sides. This 2 stays exactly the same. I end up with 2k's. Our inverse and identity properties tell us that that crosses off, so all that's left over here is negative 6. And now this looks just like a problem we did yesterday. I'm going to move the 2 over using the subtraction property. I get 2k equals negative 8. And then using our division property, I can divide. So I end up with k equaling negative 4. And remember, you can always plug these in and check them, so you should know if you're getting them right or wrong. The difference with these is we're going to have to plug this in 2 different places. So for both k's, I'm going to replace it with negative 4. So on this side, I end up with 2 plus a negative 20, and I want to know if that's equal to negative 12 minus 6. And on both of these, we get negative 18. So we know we did the problem correctly. Now this next one's a little different because even though we have variables on both sides, there's only numbers on one side. So because of that, I'm going to move my variables to the other side. So subtract 3w from both sides. This crosses off. I get 2 equals 4w. Now I can divide both sides by 4 and end up with w is 1/2. And you can leave it like this, or you could rewrite it as this because of the symmetric property. So let's try some with grouping symbols. So sometimes you need to actually simplify before you can start solving. So that's what we're going to do here. We're going to get rid of the grouping symbols, and then we're going to solve the problem just like the last one we did. So this 8s is going to stay the same. Actually, you know what? I'm going to change all these to x's because s's look like 5s. So 8x minus 10 equals, we'll distribute this, so 3 times 6 is 18, and 3 times negative 2x is negative 6x. So now we get to make our choice on what side we want to put the variables. And remember, there's no wrong answer here, but because this one's negative, I'm going to move it over to the other side. If you're finding yourself getting messy, draw a nice little line through your equation. Make sure that you're keeping things on both sides. So this will give me 14x minus 10, and that equals just 18 over here, because remember those cross off. So now that all my x's are on the left side, I want to move all my numbers to the other side. So the opposite of negative 10 is positive 10. We'll cross those off. So all that's left over here is 14x, and that's the same as 28. So now 14 and x are multiplying, so to undo that, I just have to divide. So we get x equals 2. And just like every single problem in this chapter, you can plug that back in and make sure that you did it correctly. So let's do one more together. Draw our nice little line down. And before I can do anything else, I'm going to get rid of the parentheses on both sides. So if I distribute this 7 here, this turns into 7n minus 7. Watch your negative sign here. If I distribute a negative 2, I get negative 6 minus 2n. And then we get to choose what side we want to put this on. Doesn't really matter. I'm going to put it on the left. That's usually my go-to. Let's move this over. So those cross off, and 7n plus 2n gives me 9 of them. And all that's left on the right side is a negative 6. So then I can add 7 to both sides because we want to get the numbers on the opposite side of the letters. And when you add this, you get 1. And then we can use our division property, divide both sides by 9. So we get n is 1/9. Let's try one more together, and then I'll leave this one for you to do on your own. So this one here is really messy, but I see some parentheses here, so I'm going to get rid of these by using the distributive property. And then before I start moving things from side to side, you always want to make sure that each side of your equation is as simple as possible. So when I look at the left side over here, it's not as simple as possible. I have two things that are alike that I can combine. So the 7x and the 5x, I can add together and get 12x's minus 5. And on this side, everything is combined already, so I end up with negative 5 plus 12x. So now pick what side you want your x's on. Doesn't really matter. Let's move them all to the left. So I'll subtract 12x from both sides. And something very strange happens. They cross out over here, but they also cross out over here. And all I have left is negative 5 equals negative 5. And because negative 5 will always equal negative 5, this is the reflexive property, that means that the answer to this problem is all real numbers. Every single number you can think of will make this equation true because the left side and the right side are exactly the same. Now if you got something like negative 5 equals 4 at the end, negative 5 will never equal 4, and that's how you know that something has no solutions. So give 3b a try on your own after we've done the rest of the notes. And let's do a story problem together. We want to find the value of x so that the figures have the same area. So what we got to do is find the area for each shape, and then we want them to be the same, which means we got to set them equal. So this more square looking one, let's start with this one. Remember, area is length times width. So whatever one you want to call length and whatever one you want to call width, all we got to do is multiply those together. So 10x is the area of this guy. Now when we look over here, it tells us that one part of this is 3 and one part of this is x. So this entire length right here is x plus 3. And we got to multiply that by 6. So that's our area. Now because we want these areas to be the same, our algebra problem becomes 10x equals 6 times x plus 3. And now it looks like all the other problems that we've done, we're trying to get x by itself. The first thing we're going to do is distribute. And then we'll subtract 6x from both sides. This crosses off here, so we get 4x equals 18. And then we got to divide both sides by 4. So 18 divided by 4 is not a nice pretty number, but that's okay. 4 goes into 18, not evenly, but 2 goes into both of them. So you could write it like this, or you could change it to 4.5 or 4.5. But whatever you do, make sure that it works. So plug this in. If your answer is 4.5 and this is 10, that means my area is 4.5 times 10, or 45. This over here is 4.5 plus 3, so that's really 7.5 times 6. And if you multiply 7.5 times 6, 6 times 7 will give you 42, 43, 44, 45. Got one decimal, it gives you 45. Same area for both of them. So try these two on your own, and this one that we left back here. We will go over them in class on Monday, so make sure you write down any questions you have, and we can talk about them then. Enjoy your weekend.